variable, in short, is a name we can use to refer to a value. Okay. Now there's some exceptions to this, but that will cover 99% of the cases you see. And the others are more advanced concepts or a convenience issue where it could be that way, but it doesn't have to be. Okay. So variables are associated with types. Ladies and gentlemen, values are associated with types. And when you declare a so-called declare variable, when you state, I want a variable to hold a value, you have to specify what types of values can go in there, okay? So you have to say this can hold a double, this can hold an int, this can hold a boolean, this can hold a reference to a string, this can hold a reference to a person, this can hold a reference to any object, person or deer or mosquito or what have you, okay? And so we talk about declaring a value. We indicate its name and its type. And we may indicate its initial value. We may say, I want this to be in there originally. A variable's value can change over time. The location, therefore, the contents of the location change over time. It holds different values over time. So if we were to go into some of our models and look at the code, we'd see a lot of declarations of variables. So here, for example, is main m equals get main. Double x equals get x. Double y equals get y. These are declaring variables, okay? So this thing here on the far left is the type. It says what sorts of values can go into the location associated with that variable. There's then the name of the variable, here m. And then this thing after the equal sign is just the initial value of that variable. So this is saying there's a thing called x, it's a location, and it can store doubles, and this is where you get its initial value, get x. This thing called y, can store doubles, but get y. Okay. And these declare integer variables, as we call them, C and R. Okay, so here we have variables defined. Okay, now we can have expressions that denote location. This is the most subtle thing we'll be talking about probably today. Expressions can denote locations. Okay, so one type of expression that can denote a location is a variable name. But we can have other things that denote locations, like this dot color. Color can be the variable name associated with this, and this dot color is a reference to that same location associated with that variable, color, in the object referred to by this, my color. P dot ethnicity is the location associated with ethnicity variable in P. This dot get main dot population size is a reference to the location associated with a population size variable in my main the main object associated with me. Or I may have A of 20, and that's a reference to the location associated with the 21st element of this A of this array called A, or B of I. And if we have these expressions, we can assign to them, okay? So we could say age equals 0. This is implicitly probably this dot age equals 0. This dot color equals color red. This p dot ethnicity equals random ethnicity. This is assigning, it's putting a value in that location. In this case, it's in this variable color referred to as part of my color. Here it's putting it into this variable called ethnicity referenced by this reference P. Okay? Again, this is just a value. This is just a value. It's just sticking it into this location. This goes through a big process to figure out what location to stick it into. It's location associated with population size, and then it sticks it in there. Okay, so we call these L values. These are sort of names for these locations, okay? Variables are important because they provide us a way of sort of naming values that can change over time. Yeah.
So if you had multiple agents, so if color was a property associated with multiple agents, and you just said color equals color dot red, would that assign that to all of them universally?
No, because secretly what's going on is, so like this age, this is a lie. See where it says age equals 0? That's just a, what I'm omitting there is something critical. Whose age? Implicitly it's this dot age, okay? So if I just said this, if I, I'm not going to do that. That sort of thing. Okay, if you see this, if I didn't have this here, right? But just color equals color dot red. Secretly there's a this on it. If you omit something in there, it's somebody's, well, okay. I got to be a little bit careful, because I'm referring to something that I'm going to explain here. Okay, so I realized I haven't gotten to one point yet, that I'm going to introduce in just a minute. But these things here are called local variables. This is a name it's just a name for a location associated with this, and it's not my m actually. It's just some m that's temporarily named in this code here. So I actually here, if I refer to C or to R, there's no this dot C or this dot R. It's just the C that's sort of used in this code here. Okay, so if I were to change C here by changing it, made it C++ or C minus or something like that. If I were to change that, that's fine. It's not going to change. All it's going to change is this C. On the other hand, if I wanted to say like if color were a property of person, right? And I said color equals color dot red. If this is in the person class, it's going to be automatically interpreted as this dot color, my color. And it always has to be some particular person's color. You can't say for everyone, just do it all in one statement. You can't do that. It has to be a particular person's color. Okay? Because this is, after all, a variable in a person, and it has to be a particular person. Okay?
So if you had color associated with the elephant, and you change something for color in the person class, it wouldn't change anything in that.
Right, and if you changed it for one elephant, it wouldn't change it for the other elephant. You'd have to, if you wanted to change it for all elephants, change their color. Or if you wanted to make all leopards change their spots, you would have to loop over them. You'd have to say, give me each one in turn. I would say, yes, sir. And here's leopard 1. And you'd say, oh, isn't he pretty? And you'd say, change the spot. And you'd say, yes, sir. It would go off.
Or I could do it when I create it. Or I could do it as I create it.
Correct. Okay. Yes.
So this is the only built-in value. Everything else is the custom object.
Yeah, and actually, this isn't even an L value. It's a reference to your own object, and you can't assign to it. An L value you can assign to. That's what's distinguished as an L value. Is so you can't actually assign to this. It's almost the only built-in keyword. It's actually another called super. Covering another project. Those are the two that I'm.
So we can assign values to?
Sorry? You can't assign values to either one. You can't assign value to this.
Oh, I see.
Oh, well, okay, yeah, and not in Java. Don't let me talk about the grossness of C++. Okay, so Java variables exist in a couple sorts, okay? So there's variables for so-called formal parameters, which are parameters on methods. There's local variables, which we just saw in that code, scattered through that code I just showed. These are local variables, so-called. They're local variables, they're just declared in some code, some statements. they exist only for the duration of those statements, and then they disappear. So we're going to go out of scope. There's fields, or so-called instance variables, which are variables associated with objects, such as a person's age, a person's color. There's some class variables associated with a class rather than particular objects of the class. And then there's a few other types of variables, not really covered here, but that are quite a bit rarer. So there's several types of variables. All of these variables, ladies and gentlemen, are names for location. Virtually all. All those listed here are names for location. So formal parameters, local parameters, fields, and class variables. They're all just names for locations that hold values. They hold values, and those values can change over time. Okay. The location associated with the variable only exists for a certain length of time. And we've talked about the scope of a variable, the region of the program that can see that variable. So there's a scope. So for example, if we go back and we look at this code here, the scope that can see M, you can't see M up above this point. Only things after here can see M. So the scope of it is sort of all this subsequent place. If you were to put code elsewhere in this object, it couldn't see M because this is code purely associated with this on step. So when we have a variable, you can only see it in certain places. And so parameters you can see within the map, and local variables you can see within a statement, statement with which they're enclosed. Fields, as long as the object exists, you can reference them in static class variables as long as the class is loaded. Okay, so because variables have locations, variables can be assigned to. Their values in those locations can change. Okay, so we can have A equals B, meaning the value that was in B gets put into the value that's in A. Okay, that value could be a reference, it could be a double value, it could be an integer, it could be a character. And then there's some variants of this. A plus equals B, A times equals B, A divided by equals B, etc. Plus plus A. And I'll talk about these. So these are just shorthand. These other variants are just shorthand. They could all be written in this way with some extra parts of the expression. But these are extra quick ways of writing them. And these variants provide a way of getting a value just before or after modifying it, which you have to be really careful about doing, or updating a variable based on its previous value, and then returning the resulting value. So I'm going to explain these because you see these a fair bit. So if you have A++ here, so imagine you had A equals